Hello friends, how are all of you? I think you are all fine. I am also fine. I have come back today with a new problem on electrostatics. Before I am going to discuss about my problem, a reminder for my new viewers. Please subscribe my channel and tap on the bell icon. Okay, here is our problem. An electron is placed at the center of a uniformly positively charged ring. The radius of the ring is A and the total charge on the ring is plus Q. Here we will set up three different situations. First, I will discuss when the electron is at rest at the center of the ring, and the second, the electron is displaced by an amount x along the axis of the ring from the center. In the second situation, two conditions may arise. Number 1, when the ring is very small and the displacement x is much larger than the radius of the ring. And the second condition is the size of the ring is very large, that is the radius of the ring is much larger than the displacement. Before going to discuss about our problem, we recall the formula of the electric field intensity at a point on the axis of a charged ring. Here the expression of the electric field E is 1 by 4 pi epsilon naught q x divided by s square plus x square whole to the power 3 by 2, and the direction of the electric field is away from the center of the ring. I have derived this formula in the previous video and the link is given in the description box. Now, what will happen if the electron is at rest at the center of the ring? According to our previous relation, the electric field at the center of the ring, that is at x equal to 0, E equal to 0. This is why the force on the electron is 0 and therefore the electron remains at rest at the center. Now, the electron is slightly displaced from the center of the ring along the axis. Here the size of the ring is very small and the displacement x is much larger than the radius of the ring. Here the electric field E is approximated to 1 by 4 pi epsilon naught q by x square, as the displacement x is much larger the radius of the ring, and the force on the electron is given by F equal to charge into electric field intensity, that is minus 1 by 4 pi epsilon naught q e divided by x square. Here the displacement and the force are oppositely directed, and this force is directed towards the center of the ring. Therefore, the electron moves towards the center, and when it reaches at the center, the force is 0. But due to its motion, the electron crosses the center of the ring. When it crosses the center of the ring, the direction of the force is reversed. Therefore, the electron again moves towards the center from left to right, and the motion is repeated. Hence, the motion of the electron is oscillatory in this condition, but the motion is not periodic because the force is not directly proportional to the displacement of the electron. Now, I discuss the situation when the ring is very large, that is the radius a is much larger than the displacement x. Here the electric field E is approximated to 1 by 4 pi epsilon naught q x divided by a cube, and this is along OP, that is away from the center of the ring. Therefore, the force on the ring F equal to minus 1 by 4 pi epsilon naught QE x by a cube. This force is directed toward the center of the ring, that is the force and the displacement are oppositely directed. Here we see that the force is directly proportional to the displacement x. This is the characteristics equation of the simple harmonic motion, and therefore the electron oscillates simple harmonically. Now we find out the frequency of the oscillation and the time period of the oscillation. If m is the mass of the electron, then we know force F equal to mass into acceleration, and this is equal to minus 1 by 4 pi epsilon naught QE x by a cube. Therefore, the acceleration equal to minus QE x by 4 pi epsilon naught m a cube, and the acceleration equal to minus omega square x, where the constant omega equal to under root QE x by 4 pi epsilon naught m a cube. This is the angular frequency of the oscillation of the electron, and the time period of oscillation capital T is given by 2 pi by omega, and we get the time period T equal to under root 16 pi cube epsilon naught m a cube by QE.